Today we're looking at adding and subtracting polynomials. But before we get into the actual adding and subtracting, we should understand what polynomials are. Now, polynomials are the sum of monomials, and monomials are a product of variables with positive integer exponents and numbers. For instance, 10, 3x, 1/2 ab squared, negative 1.8 m to the fifth. These are all monomials. And so a polynomial would be a sum of those. Now, we want to write our polynomials in standard form whenever possible. And what that means is we go descending order of degree, which means we start with the highest exponent and work our way down. So if I had something like 15x minus x squared plus 3, I would want to start with the highest degree monomial, which is the highest exponent, x squared. So I would move the x squared to the front, and I would make sure that I took its sign with it, because it's not an x squared, it's a negative x squared. My next term would be the 15x, because it has the next highest exponent. So I'd have plus 15x. And my last term is always the constant term, the term without the variable, in this case 3. Now we define the degree of a polynomial by the highest power in the polynomial. Now, if we had a product such as 4b to the fourth c, where we have multiple variables, we add their exponents. So the b has a 4 and the c has an invisible 1. So the degree is 5. So now that we have a basic understanding of polynomials, let's look at adding and subtracting. So if I want to add two polynomials, essentially what I'm doing is something I've been doing for a while, which is adding like terms. So the first thing I want to do is identify the like terms in this sum. So which term is alike to x cubed? X cubed. So 2x cubed plus x cubed is 3x cubed. And which term is like negative 5x squared? 2x squared. And negative 5x squared plus 2x squared is negative 3x squared. Which term is like x? Well, there's no like term with x, so I don't have anything to add it to. I have just plus x. And my last term, which also is alone, is the minus 1. So there's my sum of those two polynomials. Again, all I'm doing is adding like terms. Just take a second to try this one on your own and see what you come up with. So if we identify our like terms here, we got 3x squared and x squared, which total up to 4x squared. X and 4x total up to 5x, and negative 6 and 10 total up to 4. That's what we get when we add them together. Now, subtracting polynomials requires just a little more attention. Suppose we start with 4n squared plus 5. I want to subtract negative 2n squared plus 2n minus 4. Well, we can look at it one way by taking our first 4n squared, our first term, and subtracting its like term, negative 2n squared. So 4n squared minus negative 2n squared gives us positive 6n squared, because 4 minus negative 2 is the same as 4 plus 2, which is 6. Then you notice that we don't have an n term in the first grouping, but we do in the second grouping. So if we have 0 n's in the first grouping minus 2 n's in the second grouping, we get a total of negative 2n. 0 minus 2n gives us negative 2n. And then we have 5 minus negative 4, which is the same as 5 plus 4, which gives us 9. That's our difference. Another way to look at it is to start with our difference and distribute the negative through the second term, the second polynomial. So basically what I'm going to do is take this negative here and distribute it through. So this would become positive, this would make this negative, and that would be positive, and that would be positive. And now I'm just adding the polynomials. So 4x squared and negative 3x squared is positive 1x squared. Negative 3x plus x is negative 2x. And 5 plus 8 is 13. That's just another way of looking at it. Why don't you try one of these on your own, see what you come up with. 4x squared minus 7x minus 5x squared plus 4x minus 9. Okay, so 4x squared, maybe we should distribute the negative first. Maybe that worked better for you. That would make this positive, that would become a negative, this would become a negative, and that would become a positive. So 4x squared and negative 5x squared becomes negative x squared. Negative 7x and negative 4x gives us negative 11x. And then there's no constant term in this one, so we just have a positive 9 hanging out from this term. We're all set. Let's look at a word problem. Major League Baseball teams are divided into two leagues. During the period 1995 to 2001, the attendance N and A in thousands at National and American League Baseball games respectively can be modeled by N equals negative 488 T squared plus 5,430 T plus 24,700. A is negative 318 T squared plus 3,040 T plus 25,600, where T is the number of years since 1995. Now we want to rewrite this function so it represents the total number of people attending baseball games in that time frame. So I want to add these two functions together. So I'll have a total of all the Major League Baseball games. Now, I can actually just add these in a vertical fashion by doing negative 488 T squared plus negative 318 T squared. And negative 488 plus negative 318 is negative 806 T squared. Then I add the 5,430 T plus 3,040 T, and I get 8,470 T. And I'm going to add the 24,700 and the 25,600. I'll get a total of 50,300. So this represents the total number of teams in both leagues for that period. So if I wanted to find a total number of players in a specific year, I would plug in the T value for that year and evaluate. So that's adding and subtracting polynomials. It's as simple as adding like terms. If you have any questions, feel free to ask. If not, you can move on to your homework.